this maybe 2 classes if we talk all the meningitis. But here we will be focused on bacteria caused meningitis. So what is that? What is meningitis? Meningitis, well, right here. Meningitis. First of all, this is inflammation between brain cell membrane system and cerebral spinal cord or through. So that we call it a CSF. It's an inflammation. Now, by the way, what type of the symptoms for the inflammation? Generally speaking, you have gonna heating, hurt, swelling, and you find it's a red, okay, because the blood cell is moving. But for meningitis, what are the typical symptoms? Vomiting, headache, what else? Don't forget, tough neck. This is very typical. For tough neck, confusion, lethargy, and scared to light. We have a terminology called photophobia. Okay, scared to the light. That's a symptom for meningitis. What are the pathogens will cause meningitis? This is a meningitis for bacterial cell. It is age dependent. Different age will have a relatively typical bacteria for that. So we want to talk a little bit detail. If it's 0 to 2 months, newborn kids, this is we call it a newborn. Which pathogen will cause meningitis? Lots of you know, heard about it. It's called GBS. Group B, Streptococcus agalactiae. We will mention later on about the Streptococcus agalactiae. A little bit of young kids, 2 months to 5 years old, it is type B Haemophilus influenza. We will mention this pathogen real quick. If it's adult, 5 year to 40 year old, like most of you, 20s, Neisseria meningitis. The pathogen is Neisseria meningitis. How about older people? WHO defined people more than 40 years old is older people. So I'm like 42 years old, I'm defined as older people, although I look very young, but it doesn't matter. So, Streptococcus pneumoniae is a major pathogen for meningitis. And we will all talk about this a little bit of detail, but at the beginning, we will talk about type B Haemophilus influenza. That's what it is right under here. Okay, so we want to talk about that. Haemophilus influenza, we have 2 slides to talk about. So now we move on to Haemophilus influenza. Long time ago, at the beginning, when people find this pathogen, Haemophilus influenza, You heard about influenza, avian influenza, human influenza. So people think it is a flu. Yes, it's correct. The meningitis sometimes accompanied with some of the flu-like symptoms. Okay, so people didn't care that too much, but actually it is meningitis. Second, for some of the kids, will have epiglottitis. Epiglottitis. It's very similar to a virus called the epiglottitis. So the parents didn't pay much attention to that. Also think, well, it could be a mild symptoms, but actually it's meningitis. It's more severe. So in the history, this is number one childhood disease in the United States. The very severe. Typically, we mentioned already, 2 months to 5-year-old kids. Little bit older than the newborn. Now, what is this bacterial looks like? This bacteria is gram-positive Coccobacillus. Coccobacillus. And tiny Coccobacillus. It's very tiny. It has a type B in capsule. Therefore, this bacteria grow on the agar is mucoid colony. What is mucoid colony? Very smelly, very heavy, like a cheese. So if you buy a pizza, the topping, if you buy cheese pizza, that heavy, smelly stuff, that's a mucoid colony. The colony on the agar looks like that. The gram-positive Coccobacillus, it's a large shape, tiny logs. The Coccobacillus, we also call it, it looks like cock cell, but it's actually a log, so we call it a Coccobacillus. Very important thing we want to mention. This pathogen, it is a fastidious bacteria. So this is go back to talk about a bacteria medium, it's a fastidious bacteria. So what means fastidious bacteria? In the clinical area, we were using 3 major agar for clinical identification. What are those 3 major agar? Is Macanthi agar, blood agar, and chocolate agar. Now what happened for this pathogen, it didn't grow on Macanthi agar. It also didn't grow on blood agar. If it's grow blood agar, we could do a good isolation. We could know it's alpha, beta, or gamma hemolytic. That's a good thing. However, it didn't grow. It only grew on chocolate agar. Remember, chocolate agar is blood agar heated at 70 degrees Celsius, turns brownish. It's for fastidious bacteria. So it's very picky to grow. You need to use chocolate agar to grow. That's another thing. All the time, it's difficult to identification. Another thing we also want to mention. This fastidious bacteria need a very special nutrients to grow. XV factors. So what are they? We're using agar plates, just a neutral agar plates. We put factor X. We put factor V. The bacteria will not grow. It's transparent. However, if we are adding XV together, we will see a bacterial growth around it. It's very interesting. Now, what is X? is hemine. That is one ingredient in the blood agar. What is V? NAD. We'll talk real quick in the biochemistry section. Nicotinic adenine dinucleotides. So it's very picky. The XV factor to grow on the neutral agar. You just strict on the neutral agar, you won't grow. And then later on, people want to isolate. Because Streptococcus ammonia, because Staphylococcus aureus could cause ammonia, and could be caused like flu-like symptoms. So people get the isolation. They find that very interesting, the weird symptoms, a weird phenomenon in there. What it looks like. Let's say I have a blood agar. Okay, this is a red blood agar. And I'm going to grow Staphylococcus aureus. We did a couple of times in the lab already. And then I grow Haemophilus influenza. What happened? It's very interesting. It grows there. And it grows surrounded the Staphylococcus aureus. So we call it, this is a satellite phenomenon. Satellite growth. Now why? We talk about XV factor. X factor is hemine. V factor is NAD. On the blood agar, it already has hemine. And the Staphylococcus aureus grows there as aerobic bacteria. They will generate NAD. So they could surround it to grow in the blood agar with Staphylococcus aureus because it supplied X factor hemine and V factor nicotinic adenine dinucleotides, which is NAD. So it's a very interesting phenomenon for that. And this slides will explain to you the type of B Haemophilus influenza. Now, why people have to do this? Because in the history, when people recognize this bacteria, there is another very similar Haemophilus will be grown surrounded the V factor. That is Haemophilus parainfluenza. Look at how similar it is. This is called Haemophilus parainfluenza. And this is the Haemophilus influenza. Only 4 letters difference. But this bacteria will not cause meningitis. Instead, it will cause endocytosis. Endocytosis, which is inflammation of the heart valves. Okay, we will mention it on again. That will have another pathogen called it. So that's why in the history people are doing that. We mentioned about that. So Haemophilus influenza is a very important one. Another pathogen we really want to talk here because it's related to all of you. Also cause meningitis is Neisseria meningitis. Okay, so the first one we want to talk about is Neisseria meningitis. So Neisseria, Neisseria. Later on, we will mention another pathogen, Neisseria gonorrhea. Same genus name, different species name. So when you see Neisseria meningitis, you already see the genus name is, the species name is meningitis. It will cause meningitis. Very interesting. Look at the characteristics on the picture. What is that? Gram-negative, coccile. Or we say Coccobacillus. But what is the arrangement? It looks like this. Did you drink coffee in the morning? Did you make coffee by yourself? What it looks like? Coffee bean. coffee bean shape. It is also dipropoxide. So, very interesting. If you have a tough neck, and then you go to see a doctor, have a couple of days didn't recover, the doctor very possible is get CSF from you, cerebral spinal fluid, and very quick they could cultivation this bacteria. If they find this is gram-negative Coccobacillus and the coffee bean shaped, by the way, it is surrounded with so many white blood cells, it is Neisseria meningitis. Why it is so important? Is a risk group 5-year-old to 40-year-old adults. And I tell you one thing, who is the risk group? Undergraduates in the university. And nobody talk about these days because we all talk about COVID-19. Back in 20 years, this is a risk. And in the library, in the cinema or in the theater, in the stadium, this indoor stadium, it will be transferred. And the people doesn't recognize that because the symptom at the beginning is not lethargy, is not vomiting, it is tough neck. So it is very easy to be recognized as a muscle pain. And there is a true story about that. The guy called Ryan from Indiana University in Bloomington, not far away from here. He was undergraduate. One day he had a tough neck. So he didn't go to school. He stayed in the dorm. And the second day his feeling is recover a little bit, but still tough, then stay in the dorm. And the third day he's even dehydrated, and the roommates take him to the hospital, Indiana University Medical Center. Then the doctor says, you come in here, if a couple of hours later we can save you. And finally they diagnosed it is meningitis. And Ryan survived, and he's biology major students like some of you, and later on he graduated, he works at the CDC, and right now he's even support for the foundation for the meningitis. The kind of to do the treatments and the prevention for some of the advertisement, whatever you call it. By the time, it is very tough. Why? Neisseria meningitis in the United States will cause the disease. The serological typing is right there, is A, B, C, Y, and W 135. Now, what's the tricky thing is that we know the best way to prevent bacterial disease. Obviously, we could use antibiotics, but that is later. For the prevention, we need to use the vaccine. So by the time before 2010, there is a vaccine called monoamine, or we say it's MPSV4 or MCV4. They could cover A, C, Y, and W 135, MCV4, for example. However, in the United States, the major serological typing is B. And this is responsible for 60% of the case in the United States for undergraduates. So by the time, there's a big debate between some universities. In California and Connecticut, they want all the students to have the vaccination, mandatory. Otherwise, you cannot register for the class. But there is a big debate behind that, because even you do the manual means MCV4 vaccination, you only have roughly 40% protection. It's less than 50, is that right? So think about this way, you get or you not get naturally 50%, then your vaccine is only 40%. So people don't want to do it. And lots of debate by the time, but later on, after 2010, around 2012, people get the cloaking from the cell membrane system and the cell wall system, very similar to what you today find in the S protein of the coronavirus. They got the protein from the type B serological bacteria, and they generate a new vaccine, and that can be successfully cover the type B. That's why in the recent 10, 15 years, nobody mentioned about Neisseria meningitis anymore, because we have a new vaccine for that. Okay, so this is a little bit of story behind that for the undergraduates. Something related to the bacteria characteristics, what we measure. We talk about the gram-negative Coccobacillus, coffee bean shape. This is also a fastidious bacteria. And this bacteria only grow on chocolate agar. And same as Haemophilus influenza. And we could do a very simple test for Neisseria meningitis. Is we could do an oxidase test. We will do this in the lab, but not Neisseria meningitis. It's oxidase test positive. Okay, so I'll just mention this because we're going to do this in the lab. Real quick, we can do this, so oxidase test positive. And very interesting also on the chocolate agar, this is a pushable colony. That's why I said colony morphology sometimes doesn't matter. For this special bacteria, it's a pushable colony. Looks like somebody pulling you away. So it could be recognized on the chocolate agar. Okay, so that's Neisseria meningitis. Last one we want to mention here is Bordetella pertussis. This is not related to the meningitis, that's another topic, so we will be relatively briefly mention here what happened. So that's called a Bordetella pertussis. Now, first of all, we just mentioned it shouldn't be a problem in the United States because vaccine DTaP P can be covered Bordetella pertussis. So it shouldn't be a big problem. Same thing, this is gram-negative Coccobacillus. So not surprised, lots of these are gram-negative Coccobacillus. We don't really talk about isolation too much. It's relatively special. What is the typical symptoms for Bordetella pertussis? It will cause whooping cough. And this whooping cough, typically for kids, around 100 days after born. So this disease in some of the country, let's say in China, in the Asian country, this is also called 100-day cough. Very typical. After like roughly 3.5 months, the kids have it if they don't have a vaccine. What is a whooping cough? Something like cough, cough, then you have a like that. So we call it productive cough with respiratory gasp. And there is 2 stages. First stage, couple of days, 7 days, people doesn't recognize, just colonization. Later on, we'll have a whooping cough. When you get the whooping cough, you have to see the doctor. Okay, same thing. Cytotoxin, so antitoxin needs to be antibiotics, you need to. Now, there is a very interesting thing I want to mention. How people diagnose this. This is really something special. Because it's a whooping cough, like 3 months newborn, it's difficult to get a sample. So what the methods they do, later on in life, 20 years ago, people have a new method. Okay, somewhere like that. What they do, They're using a swab. The swab is going to go into the nose to get the sample. It is a swab. But how deep it should be? You can't just touch on the surface. You need to be a little bit deep. Where it should be, they need to measure the distance between earlobe to the nose. And how deep it is? Half. So it should be the half size, the half distance between the nose and the earlobe. That's what the depth the swab should go there. And I also want to mention this swab is not a general swab. You could use cotton swab, but lots of people do the research find the cotton swab, the recovery of the pathogen is not very successful. So you need to use a very special media, this media called a Decon swab. When you get the Decon swab, you keep the sample, you go to reference lab, and the reference lab could use fluorescence PCR, polymerase chain reaction. They could do a very quick identification. So it's very interesting. That's a message what they do. But we also want to mention that in the United States, this doesn't talk too much right now because we have a vaccine. But history, it is important. This research done back like 2005, about like 20 years ago, people have a new method to identification. Okay? So this is budgetary purposes. Before the end of this class, I would re-emphasize these slides. So Thursday, we're going to talk about streptococcus and staphylococcus. It will be a big topic. These slides give you an introduction. So don't forget, what is this agar? It's a blood agar. We will do a test next week in the lab. Blood agar is an enrichment media. Bacteria can grow dramatically. But it is a differentiated media. You're going to have alpha hemolytic, beta hemolytic, and gamma hemolytic. Alpha hemolytic, look at the picture, green color, incompleted hemolysis of the blood cell. The good example, streptococcus pneumoniae. Beta hemolytic, completely hemolysis, blood agar. A good example, streptococcus pyogenes. And there is another one called gamma hemolytic, which means nothing happened. And this is the slides as an outline.